The Lockheed Martin Boeing F-22 Raptor is an American twin-engine, jet-powered, all-weather, supersonic stealth fighter aircraft. As a product of the United States Air Force's Advanced Tactical Fighter ATF program, the aircraft was designed as an air superiority fighter, but also incorporates ground attack, electronic warfare, and signals intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22 airframe and weapon systems and conducted final assembly, while program partner Boeing provided the wings, aft fuselage avionics integration, and training systems. First flown in 1997, the F-22 descended from the Lockheed YF-22 and was variously designated F-22 and F-22 before it formally entered service in December 2005 as the F-22A. It replaced the F-15 Eagle in most active-duty U.S. Air Force USAF squadrons. Although the service had originally planned to buy a total of 750 ATFs to replace its entire F-15 fleet, it later scaled down to 381, and the program was ultimately cut to 195 aircraft, 187 of them operational models in 2009 due to political opposition from high costs, a perceived lack of air-to-air threats at the time of production, and the development of the more affordable and versatile F-35 Lightning II, and the last aircraft was delivered in 2012. The F-22 is a critical component of the USAF's tactical air power as its most advanced air superiority fighter. While it had a protracted development and initial operational difficulties, the aircraft became the service's leading counter-air platform. Its deployments include Okinawa, the Middle East, and NATO's eastern flank. Although designed for air superiority operations, the F-22 has also carried out and supported airstrikes in Syria, Afghanistan, Iran, and Venezuela. The F-22 is expected to remain a cornerstone of the USAF's fighter fleet until its successor, the Boeing F-47, enters service around 2030. The F-22 Raptor is a fifth-generation air superiority fighter that is considered fourth generation in stealth aircraft technology by the USAF. It is the first operational aircraft to combine supercruise, super maneuverability, stealth, and integrated avionics or sensor fusion in a single weapons platform to enable it to survive and conduct missions, primarily offensive and defensive counter-air operations, in highly contested environments. The F-22's shape combines stealth and aerodynamic performance. Planform and panel edges are aligned at common angular aspects, and the surfaces, also aligned accordingly, have continuous curvature to minimize the aircraft's radar cross-section. Its clipped diamond-like delta wings have the leading edge swept 42-degree, trailing edge swept 17-degree, a slight anhedral and a conical camber to reduce supersonic wave drag. The shoulder-mounted wings are smoothly blended into the fuselage with fore empennage, surfaces and leading edge root, extensions running to the carette inlet's upper edges, where the four-body Chinese also meet. Flight control surfaces include leading edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all moving horizontal tails, stabilators. For air braking, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. Owing to the focus on supersonic performance, area rule is applied extensively to the airplane's shape, and nearly all of the fuselage volume lies ahead of the wing's trailing edge to reduce drag at supersonic speeds, with the stabilators pivoting from tail booms extending aft of the engine. Nozzles. Weapons are carried internally in the fuselage for stealth. The jet has a retractable tricycle landing gear and an emergency tailhook. Fire suppression system and fuel tank inerting system are installed for survivability. The aircraft's dual Pratt & Whitney F-119 augmented turbofan engines are closely spaced and incorporate rectangular two-dimensional thrust vectoring nozzles with a range of plus 20 degrees in the pitch axis. The nozzles are fully integrated into the F-22's flight controls and vehicle management system. Each engine has dual redundant Hamilton standard full authority digital engine control, FADEC, and maximum thrust in the EO 35,000 lbf 156 km class. The F-22's thrust-to-weight ratio in typical combat weight is nearly at unity in maximum military power and 1.25 in full afterburner. The fixed shoulder-mounted Carette inlets are offset from the forward fuselage to bypass the turbulent boundary layer and generate oblique shocks with the upper inboard corners to ensure good total pressure, recovery, and efficient supersonic flow. Compression. Maximum speed without external stores is approximately Mach 1.8 in supercruise at military intermediate power and greater than Mach 2 with afterburners on 17 with 18,000 lb, 8,165 kg of internal fuel and an additional 18,000 blendo, 3,629 kg into 6 gallon external. Depending on the detected threat, the defensive systems can prompt the pilot to release countermeasures such as flares or chaff. To ensure stealth in the radio frequency spectrum, the ASQ-220 CNI emissions are strictly controlled and confined to specific sectors, with tactical communication between F-22s performed using the Directional Inter-Intraflight Data Link IFDL. The CNI system also manages TACAN, IFF including Mode 5, and communication through various methods such as Have Quick Saturn, SINGARS, and later Link 16 RMD. Additional passive detection methods include the Air-56 missile launch detector, which uses 6 sensors to provide full spherical infrared coverage. The sensors are being updated to the TAC-EARS-T for improved detection and survivability measures. Separately, the advanced IRS-T, housed in a stealthy wing pod, is a narrow field of view sensor for long-range passive identification and targeting. The aircraft was also upgraded with an automatic ground collision avoidance system. GCS, a SIP unit for the F-22. Information from radar, CNI, and other sensors are processed by 2 use Common Integrated Processor, CIP, mission computers, each capable of processing up to 10.5 billion instructions per second. The F-22's baseline software has some 1.7 million lines of code, the majority involving the mission systems such as processing radar data. The highly integrated nature of the avionics architecture system, as well as the use of the programming language Ada, N-21 has made the development and testing of upgrades challenging. To enable more rapid upgrades, the CIPs were upgraded with Curtiss-Wright Open Mission Systems, OMS, processor modules, as well as a modular open systems architecture called the Open Systems Enclave, OSE, orchestration platform to allow the avionics suite to interface with containerized software from third-party vendors. The F-22's ability to operate close to the battlefield gives the aircraft threat detection and identification capability comparative with the RC-135 rivet joint and the ability to function as a mini AWACS. Though its radar is less powerful than those of dedicated platforms, this allows the F-22 to rapidly designate targets for allies and coordinate-friendly aircraft. Although communication with other aircraft types was initially limited to voice, upgrades have enabled data to be transferred through Battlefield Airborne Communications, Node, BACN, or via JTI's link. 16 traffic through MIDS JTRS, the IE-1394B bus developed for the F-22 was derived from the commercial IE-1394 Firewire bus system. In 2007, the F-22's radar was tested as a wireless data transceiver, transmitting data at 548 megabits per second and receiving at gigabit speed, far faster than the Link 16 system. The aircraft's radio frequency receivers provide electronic support measures, ESM, and the ability to perform intelligence, surveillance, and reconnaissance, ISR tasks. Tanks. The jet has a ferry range of over 1,600 nmi, 1,840 meter, 316 kilometer. The aircraft has a refueling boom, receptacle centered on its spine, and an auxiliary power unit embedded in the left wing root. Rear view of jet aircraft in flight at dawn dusk above mountains. Its engines are in full afterburner, evident through the presence of shock diamonds. F-22 flying with its Pratt & Whitney. F-119 engines on full afterburner during testing. The F-22's high cruise speed and operating altitude over prior fighters improve the effectiveness of its sensors and weapon systems and increase survivability against ground defenses such as surface-to-air missiles. Its ability to supercruise or sustain supersonic flight without using afterburners, allows it to intercept targets that afterburner-dependent aircraft would lack the fuel to reach. The use of internal weapons bays permits the aircraft to maintain comparatively higher performance over most other combat-configured fighters due to a lack of parasitic drag from external stores. The F-22's thrust and aerodynamics enable regular combat speeds of Mach 1.5 at 50,000 feet, 15,000 meter, thus providing 50% greater employment range for air-to-air missiles and twice the effective range for JDAMs than with prior platforms. And for its structure contains a significant amount of high-strength materials to withstand stress and heat of sustained supersonic flight, respectively. Titanium alloys and bismulimide epoxy composites comprise 42% and 24% of the structural weight. The materials and multiple load path structural design also enable good ballistic survivability. The airplane's aerodynamics, relaxed stability, and powerful thrust vectoring engines give it excellent maneuverability and energy potential across its flight envelope, capable of 9G maneuvers at takeoff. Gross weight with full internal fuel. Its large control surfaces, vortex-generating Chinese and lurgs, and vectoring nozzles provide excellent high alpha angle of attack characteristics, and is capable of flying at trimmed alpha of over 60 days while maintaining roll control and performing maneuvers such as the Herbst maneuver, J-turn, and Pugachev's Cobra. R-54 vortex impingement on the vertical tail fins did cause more buffeting than initially anticipated, resulting in the strengthening of the fin structure by changing the rear spar from composite to titanium. The computerized triplex redundant fly-by-wire control system and FADEC make the aircraft highly departure resistant and controllable, thus giving the pilot carefree handling. Stealth. Edit. For stealth, the F-22 carries weapons in internal bays. The doors for the center and side bays are open. 4 LAU-142A AMRAAM vertical eject launchers, AVL, are visible. The F-22 was designed to be highly difficult to detect and track by radar, with radio waves reflected, scattered, or diffracted away from the emitter source towards specific sectors, or absorbed and attenuated. Measures to reduce RCS include airframe shaping such as alignment of edges and continuous curvature of surfaces, internal carriage of weapons, fixed geometry serpentine inlet, ducts and curved vanes that prevent line of sight of the engine fan faces and turbines from any exterior view, use of radar-absorbent material, RAM, and attention to detail such as hinges and pilot helmets that could provide a radar return. The F-22 was also designed to have decreased radio frequency emissions, infrared signature, and acoustic signature, as well as reduced visibility to the naked eye. The aircraft's rectangular thrust vectoring nozzles flatten the exhaust plume and facilitate its mixing with ambient air through shed vortices, which reduces infrared emissions to mitigate the threat of infrared homing, heat-seeking, surface-to-air or air-to-air missiles. Additional measures to reduce the infrared signature include special top coat and active cooling to manage the heat buildup from supersonic flight. Compared to previous stealth designs, the F-22 is less reliant on RAM, which are maintenance-intensive and susceptible to adverse weather conditions, and can undergo repairs on the flight line or in a normal hangar without climate control. The F-22 incorporates a signature assessment system which delivers warnings when the radar signature is degraded and necessitates repair. While the F-22's exact RCS is classified, in 2009 Lockheed Martin released information indicating that from certain angles the airplane has an RCS of 0.01 or 40 dBSM, equivalent to the radar reflection of a steel marble. The aircraft can mount a Lundberg lens reflector to mask its RCS octamirrored. For missions where stealth is required, the mission-capable The effectiveness of the stealth characteristics is difficult to gauge. The RCS value is a restrictive measurement of the aircraft's frontal or side area from the perspective of a static radar. When an aircraft maneuvers, it exposes a completely different set of angles and surface area, potentially increasing radar observability. Furthermore, the F-22's stealth contouring and radar absorbent materials are chiefly effective against high-frequency radars, usually found on other aircraft. The effects of Rayleigh, scattering, and resonance mean that low-frequency radars such as weather radars and early warning radars are more likely to detect the F-22 due to its physical size. These are also conspicuous, susceptible to clutter, and have low precision. Additionally, while faint or fleeting radar contacts make defenders aware that a stealth aircraft is present, reliably vectoring interception to attack the aircraft is much more challenging. Avionics. Edit. An F-22 releases a flare during a training flight. The aircraft has an integrated avionics system where, through sensor fusion, data from all onboard sensor systems as well as offboard inputs are filtered and processed into a combined tactical picture, thus enhancing the pilot's situational awareness and reducing workload. Key mission systems include Sanders General Electric and ALR-94 Electronic Warfare System, Martin Marietta AN/AR Canisi Infrared and Ultraviolet Missile Launch Detector MLD, Westinghouse Texas Instruments AN/APG-77 Active Electronically Scanned Array ASA Radar TRWN ISQ to order, Communication, Navigation, Identification CNI Suite and Raytheon, Advanced Infrared Search and Track IRST being tested. The APG-77 radar has a low-observable, active aperture, electronically scanned antenna with multiple target track while scan. In all weather conditions, the antenna is tilted back for stealth. Its emissions can be focused to overload enemy sensors as an electronic attack capability. The radar changes frequencies more than 1,000 times per second to lower interception probability and has an estimated range of thought Donan 1-241 km against an 11 SQFT 1 Matu target and 250 MA 400 km or more in narrow beams. The upgraded APG-77 V.1 provides air-to-ground functionality through synthetic aperture radar, SAR, mapping, ground moving target indication track, GMTI, GMTT, and strike modes. The ALR-94 electronic warfare system, among the most technically complex equipment on the F-22, integrates more than 30 antennas blended into the wings and fuselage for all-round radar warning receiver RWR, coverage and threat geolocation. It can be used as a passive detector, capable of searching targets at ranges, 50 pmi, exceeding the radars, and can provide enough information for a target lock through narrowband, interleaved search and rack NBLST, and cue radar emissions to a narrow beam, down to 2 degrees by 2 degrees azimuth and elevation. The F-22 has a glass cockpit with all digital flight instruments. The monochrome head-up display offers a wide field of view and serves as a primary flight instrument. Information is also displayed upon 6-color liquid crystal display LCD panels. The primary flight controls are a force-sensitive side stick controller and a pair of throttles. The USAF initially wanted to implement direct voice input, DVI controls, but this was judged to be too technically risky and was abandoned. The canopy's dimensions are approximately 140 inches long, 45 inches wide, and 27 inches tall, 358 cmx 1 and mid-x69 cm and weighs 360 pounds. The canopy was redesigned after the original design lasted an average of 31 hours instead of the required 800 hours. Although the F-22 was originally intended to have a helmet-mounted display HMD, this was deferred during development to save costs. The aircraft is currently integrating the Scorpion HMD. The F-22 has integrated radio functionality. The signal processing systems are virtualized rather than as a separate hardware module. The Integrated Control Panel, ICP, is a keypad system for entering communications, navigation, and autopilot data. Two 3 and X4 and 7.6 cm x 10.2 cm upfront displays located around the ICP are used to display integrated caution, advisory warning ICAW data, CNI data, and also serve as the standby flight instrumentation, group and fuel quantity indicator for redundancy. The standby flight group displays an artificial horizon for basic instrument meteorological conditions. The 8 and X8 and 20 x 20 cm primary multifunction display PMFD is located under the ICP and is used for navigation and situation assessment. 3 6.25 and X6 25 and 15.9 CMX 15.9 Indian or secondary multifunction displays are located around the PMFD for tactical information and stores management. The ejection seat is a version of the ACES II commonly used in USAF aircraft with a center-mounted ejection control. The F-22 has a complex life support system, which includes the onboard oxygen generation system, OBOGs, protective pilot garments, and a breathing regulator, anti-G, brag, valve controlling flow and pressure to the pilot's mask and garments. The pilot garments were developed under the Advanced Technology Anti-G Suit, ATAGS, project and protect against chemical biological hazards in cold water, immersion, counter G forces and low pressure at high altitudes, and provide thermal relief. Following a series of hypoxia-related issues, the life support system was consequently revised to include an automatic backup oxygen system and a new flight vest. In combat environments, the ejection seat includes a modified M4 carbine designated the GAU-5A T4 armament. Edit 1 IM-120 AMRAAM right and 4 GBU-39 SDB left, fitted in the main weapons bay of an F-22. The F-22 has 3 internal weapons bays, a large main bay on the bottom of the fuselage, and 2 smaller bays on the sides of the fuselage, aft of the engine inlets. A small bay for countermeasures such as flares is. The main bay is split along the center line and can accommodate 6 La-142A launchers for beyond visual range. BVR missiles in each side bay has an La-142A launcher for short-range missiles. The primary air-to-air missiles are the AIM-120, AMRAAM, and the AIM-9 Sidewinder, with planned integration of the AIM-260 JTM. Missile launches require the bay doors to be open for less than a second, during which pneumatic or hydraulic arms push missiles clear of the aircraft. This is to reduce vulnerability to detection and to deploy missiles during high-speed flight. An internally mounted M61A2 Vulcan 20 non-rotary cannon is embedded in the airplane's right wing root, with the muzzle covered by a retractable door, which remains closed when the cannon is not firing in order to minimize the negative effect the exposed muzzle on the aircraft's radar signature. The radar projection of the cannon fire's path is displayed on the pilot's head-up display. Although designed for air-to-air missiles, the main bay can replace 4 launchers with 2 bomb racks that can each carry one 1,000 lb 450 killer or 4 250 lb 110 killer bombs for a total of 2,000 pounds, 910 kilos of air-to-surface ordnance. In 2024, Lockheed Martin disclosed its proposed Mako hypersonic missile, weapon that can be carried internally in the F-22. While capable of carrying weapons with GPS guidance such as JDAMs and SDBs, the F-22 cannot self-designate laser-guided weapons. F-22 with external weapons pylons. While the F-22 typically carries weapons internally, the wings include 4 hardpoints, each rated to handle 5,000 lb, 300 killer. Each hardpoint can accommodate a pylon that can carry a detachable 600-gallon 270L external fuel tank or a launcher holding 2 air-to-air missiles. The 2 inboard hardpoints are plumbed for external fuel tanks. The 2 outboard hardpoints have since been dedicated to a pair of stealthy pods housing the IRST and mission systems. The aircraft can jettison external tanks and their pylon attachments to restore its low, observable characteristics and kinematic performance. Edit. Each F-22 requires a 3-week packaged maintenance plan, PMP, every 300 flight.
hours.
Its stealth coatings were designed to be more robust and weather-resistant than those of earlier stealth aircraft. 154 yet early coatings failed against rain and moisture when F-22 were initially posted to Guam in 9 Tucumcir. Stealth measures account for almost one-third of maintenance, with coatings being particularly demanding. F-22. Depot maintenance is performed at Ogden Air Logistics Complex at Hill AFB, Utah. Considerable care is taken during maintenance due to the small fleet size and limited attrition reserve. F-22 were available for missions 63% of the time on average in 2015, up from 40% when it was introduced in toward the maintenance. Hours per flight hour was also improved from 30 early on to 10.5 by 2009, lower than the requirement of 12. Man-hours per flight hour was 43 in 2014. When introduced, the F-22 had a mean time between maintenance, MTBM, of 1.7 hours. Short of the required 3.0, this rose to 3.2 hours in 2012. By fiscal year 2015, the cost per flight hour was $59,116, while the user reimbursement rate was approximately $35,000, 42 cents to $37 in 2024, per flight hour in 2019,